channel if you are from automation field or engineer. Also press bell icon to get latest video notifications on automation. Today, we are going to tell you part 1 of interview questions, which are asked in every interview of automation. Question 1. What is automation? Automation is delegation of human control functions to technical equipment for increasing productivity, better quality, reduces cost, and increased in safety working conditions. Question 2. What are the different components used in automation? The components of automation system include 1. Sensors for sensing the input parameters, 2. Transmitters for transmitting the raw signal in electrical phone, 3. Control system which includes PLC, DCS and PID controllers, 4. Output devices, actuators like drives, control valves. Question 3. What are the different control systems used in automation? 1. PID controller based control system, 2. PLC based control system, 3. DCS based control system, 4. PC based control system. Question 4. Explain PID based control system. PID, proportional integral derivative, is the algorithm widely used in closed loop control. The PID controller takes care of closed loop control in plant. A number of PID controllers with single or multiple loop can be taken on network. PID controllers are widely used for independent loops. Although some logic can be implemented, but not much of sequential logic can be implemented in PIDs. Question 5. What is difference between PLC and relay? 1. PLC can be programmed whereas a relay cannot. 2. PLC works for analog, IOs such as PID loops, etc. whereas a relay cannot. 3. PLC is much more advanced as compared to relay. Question 6. What is difference between PLC and DCS? 1. Response time. PLCs are quick. That create the PLC a perfect controller for time period actions like a safety ESD, emergency shutdown, or firing control. A DCS takes for much longer time to process information that created it not the proper resolution. Once response times are important. 2. Scalability. A few thousand I/O points will be handled by a PLC whereas DCS will handle several thousands of I/O points and accommodate new instrumentation, process enhancements, and data integration. DCS will be most popular once advanced process control is needed and contain an outsized facility that's displayed over a large geographical region with thousands of I/O points. 3. Complexity. The advanced process control capabilities of the DCS are needed to hold out the complicated nature of the many continuous production processes like oil and gas, water treatment, and chemical process. 4. Frequent process changes. PLCs are used for processes that may not modification typically. And a DCS is that the better solutions once the method is complicated and needs frequent changes or should analyze an outsized quantity of data. 5. Vendor support. To provide integration services and implement method changes, DCS vendors need users to use them. System integrator performs similar functions for PLC-based systems. It's additionally become common for PLC vendors to supply support services through their network of system measuring system partners. Question 7. What is encoder? Encoder is a feedback device which converts mechanical motion into electronic signal. Usually an encoder is a rotary device that outputs digital pulses which correspond to incremental angular motion. The encoder consists of a glass or metal wheel with alternating clear and opaque stripes that are detected by optical sensors to produce the digital outputs. Question 8. What types of sensors are used for measuring different parameters? 1. Temperature sensors, RTD, thermocouple, thermistor. 2. Pressure sensors, Bourdon tube, bellows, strain gauge. 3. Flow sensors, flow orifice, flow nozzle, venturi tube, pitot tube. 4. Level sensor. 5. Density sensor. Question 9. What is transmitter? Transmitter is an electronic device that is generally mounted in the field close to a sensor. The sensor, also known as a transducer, measures a physical variable such as temperature or pressure and outputs a very low-level electronic signal. The basic function of the transmitter is to provide the correct electrical power to turn on or excite the sensor, then to read the low-level sensor signal, amplify it to a higher-level electrical signal and send that signal a long distance to a control or readout device. Since low-level electrical signals do not transmit long distances with great accuracy, installing a transmitter generally gives a tremendous improvement in the accuracy of the information delivered to a larger control system. Typically, the output from the transmitter is 4 to 20 mA or 0 to 10 V. Question 10. Why 4 to 20 mA preferred over 0 to 10 V signal? The 0 to 10 V signal has tendency to drop because of line resistance. If the distance between sensor and input card is more, the signal will not properly represent the field value. The milliamp will travel a long distance without dropping signal value. Question 11. Why 4 to 20 mA preferred over 0 to 20 mA signal? With 0 to 20 mA, you cannot distinguish between minimum field value and connection break. With 4 to 20 mA, internal circuit can distinguish between connection break of minimum value. Normally, when the value is minimum, the transmitter will give you 4 mA, while in case of connection breakage, it will give 0 mA. So 4 to 20 mA method is preferred. Question 12. What is difference between 2-wire, 3-wire and 4-wire transmitter? In 2-wire transmitter, the power and data signal are transmitted through same cable, and cable has 2 wires only. In 3-wire transmitter, the data signal and power are transmitted with respect to common ground. Cable has 3 wires. In 4-wire transmitter, 2 wires for power supply and 2 for data signals. Cable has 4 wires. Only current transmitters can be used as 2-wire transmitters. Question 13. What is a smart transmitter? A smart transmitter is a device that is used a microprocessor as an integral unit. The smart transmitter has its own memory and it can also be programmed. It has abilities to perform calculations, do self-diagnostics, and can communicate with other devices. The most common communication protocol on which the smart transmitter is communicating with other devices is HART protocol. The HART stands for Highway Addressable Remote Transducer. A transmitter compatible with HART protocol has two outputs: the conventional analog signal of 0-10 V or 4 to 20 mA and a digitally superimposed signal. Question 14. What is field bus? A field bus is a bus system that connects sensors and actuators to a control computer, PLC, for information exchange. Each manufacturer has designed its own communication mechanisms for its field bus so that all sensors and actuators can exchange information without interference. Most field buses are based on the so-called master-slave method. X-Profibus PA, Profibus DP, CAN-open, CC-Link, DeviceNet. Question 15. What is actuator? An actuator is a device that uses a form of power to convert a control signal into mechanical motion. From electric door locks in automobiles to ailerons on aircraft, actuators are all around us. Industrial plants use actuators to operate valves, dampers, fluid couplings, and other devices used in industrial process control. The industrial actuator can use air, hydraulic fluid, or electricity for motive power. These are referred to as pneumatic, electrohydraulic, or electric actuators. Question 16. Explain working of RTDs. Resistance temperature device works on the principles that the resistance of the material changes as its temperature changes. Temperature is determined by measuring resistance and then using the RTD resistance versus temp characteristic to detect temperature. Typical elements used for RTD are nickel, copper, and platinum. Platinum is widely used in RTDs because of accuracy. PT100 means at 0 deg temp, 100 ohms resistance. A typical RTD consists of a fine platinum wire wrapped around a mandrel and covered with a protective coating, glass or ceramic. Question 17. Temperature measurement range supported by RTDs. The RTD work on temperature range between 250 to 850 degrees Celsius. Question 18. Explain working of thermocouple. Thermocouple consists of two strips or wires made up of different metals and joined at one end. The temperature at that junction induces an electromotive force, EMF, between the other ends. As the temperature goes up, the EMF also increases. Through standard charts and tables, the corresponding temperature can be found out. The relationship between the thermocouple output and the temperature is quite non-linear. Different metallurgies produce different outputs. The different metallurgies and different linearities result in different thermocouple designations as JKNL, etc. Question 19. What is cold junction compensation? The industry accepted standard for the temperature at open end is 0 degrees Celsius. Therefore, tables and chart make the assumption that the temp open end is 0 degrees Celsius. In industry, the open ends are always at actual room temperature and not 0 degrees Celsius. The EMF adjustment because of difference between the temp and 0 degrees Celsius is referred as cold correction, CJ correction. Question 20. What are the flow measuring instruments used in flow measurement? 1. Different pressure meters. 2. Positive displacement. 3. Velocity meters. Thanks for watching. Please do WhatsApp or email for any support.